Dear viewers, welcome back to School of Civil Engineering. This is Hedaetullah with another new video, Tekla Tedds. So in this lecture, I'm just going to show that how we'll design or analyze a rectangular columns, and in a previous lecture I have just shown you that how we'll design different types of beam. Okay, so to design a column, I'll just open that software. Okay, and after that I'll click here new. From here I'll just click here first of all I'm showing you about concrete design. That's why my unit is US, because you know that already I have discussed about that code. And here this is the US, okay, US unit. And so after that I'll just go here concrete, and our previous lecture I've just shown you that how we'll design our beam, and in this lecture I am just going to show that how we'll design our column. So here I am clicking column as per ACI 318, and you can select any version of ACI. So we are able to design two types of columns, circular and rectangular, and here we are able, and also we are able to design that for axial load, for biaxial or uniaxial load. Okay, so I'll show you everything about that. So first of all I'm just clicking here RCC column, and after that I'll click calculate, and here a file will be generated. Now the first work is here we have to select loading type. Which types of load? Axial only, axial or uniaxial bending, or axial or biaxial bending. Okay, so first of all I'm showing you only axial only. Okay, so here when it's done, then we have to click here column details. Okay, we have to click here column details, and before that I will suggest you select your design code, which code you want to use. So here ACI 31814, ACI 31811, and ACI 31808 and 05. So I am just using 14 ACI of, actually they have much more difference between them. So I'll just click OK. After that our design is okay, I mean our design code is okay, and here we will after that we'll use here design load. What will be the design load actually? As we are using axial only, and our section is, so here our design load, what will be our design load? How much keep actually? Okay, PU ultimate act. So here I'm considering our 100 keep. Okay, 100 keep, and here ratio of suspended load to maximum load beta D 0.6, and you have to provide that as per your design code. Okay, I mean this is the factor, a maximum ratio of factor. So I'm just clicking OK, and here you are seeing that, and here column size are given here 10 into 12 inch column with respect to that bar, 4 into 9 bars provided, and also 4 ties, I mean number 4 ties at 6 in center to center, and its capacity is 754.1 keeps, but we have provided only 100 keeps. I mean this column is able to take huge load. Now from here you have to select your column size here. Now first of all from here type of column, from here you have to select rectangular, and after that width, what will be the width of column? So with respect to 100 keep load, I will just consider that this is 10, sorry I'm extremely sorry, this is 10 inch, then also 10 inch into 10 inch, and here the clear height, and also here clear height 10 feet, okay, for about axis X and for about axis Y. In both axes this is 10 feet, and here, and also column estate, this is braced or unbraced. So this is unbraced column, also unbraced column, Okay, and you can select that as per requirement, rectangle 10 inch into 10 inch section. And here, and the most important, effective length factor. If your column are both sides supported, fixed supported, then you know that that will be 0.5, and also that side it will be 0.5. okay, so here it is. Now we'll just come here, concrete compressive strength, that will be you can give here manually. Suppose if I give a 2800, and also you are able to change that reinforced yield strength, okay, 40 or 60 bar. So I'm considering 60 bar, and here clear cover 1.5 inch, and the bar diameter, what will be the bar diameter? I will use number 6 bar, okay, because number 6 bar is okay. Also you can use number 5 bar, but the number 5 bar is the least bar, okay, and we cannot use the more than I mean 3 or 4 bar for our main reinforcement, I mean longitudinal reinforcement. And after that, how much bar will provide here? 3. If we provide here, just see 3 bar have provided in x direction, so I'll just provide 2 bar in every direction. And here lateral ties or minimum size, so I will use number 3 bar, and here it's showing us 6 inch center to center. So if I consider 8 is center to center, then see what happened. So when our every data is okay, I mean we have, after providing our every data perfectly, we'll just simply click OK, and see when everything is okay. Now we have to come here, design load. So see here, here this is 100, okay. Now see our capacity with respect to that data is 160.5, and the maximum utilization 1 on 0. Okay, so our design is okay here, as per that code our design is okay. But if we use here breast, at the breast, and here the breast, then see our capacity will increase. So here I think now okay. So here, and also our design code 3 on 8. And now just one thing, if I increase the load, suppose if I provide load 200 kips, okay, now see our design check is not okay, I mean our utilization factor is not okay. Our capacity is 160.5, but we are providing much more. Then what we'll do actually, so here what we'll do actually, I'll just again here column details. So if I increase 12 into 12, then see what happened. Okay, then area of reinforcement, I'll just see now it's okay. Okay, 1.0, here it's okay. Again I'll just go here, area of reinforcement provided 1.23 is less than the required. Okay, so if I increase the bar size, now it's okay. Okay, if you provide number 6 bar, then it's okay. And our design check is also, our reinforcement requirement is also okay. Then I'll click OK, and see this is done. Now this is for only axial. Now if you need to design that for a different, I mean uniaxial, I mean in one way moment. So if you click here, so axis of bending, x or y. If you select x, okay, then you have to come here, design load. Okay, so here this is the factor moment about x. So suppose that is 20 kip per feet, which is actually considered, it's depend on your data. So okay, and wait for some time. See our ultimate load, this is our ultimate load, and also our design capacity. Here the capacity 31.1 as per our that data. Okay, but now if we need biaxial bending, okay, if we need biaxial bending, so I'll just come here. So here this is 20, suppose this is 25. Okay, and contour beta factor you can select from here as per ACI code. Okay, so I'm taking its default. You have to change that as per your design requirement. Okay, so okay, wait for some time. So here see that moment for that on and that on. So here it's showing the capacity, but we have provided the maximum value here. So what I will do, again I'll just go loading condition. Okay, I'll just go for loading condition, and here the moment in x and y, okay, 25 and 45, and here everything is okay. Okay, everything is okay. Now what I'll do, I'll just go here. I will just increase our section size. So as in x direction our moment is maximum, so I'll increase our section in y direction. Okay, I mean I'll increase our width here 12 into 12, 20 into 15. Sorry, not that direction. 12 into 15, and also we are seeing that our requirement is, and the minimum requirement of reinforcement is not okay. So in x direction I'll also provide a extra layer of reinforcement. So here this is the extra layer of reinforcement, and our spacing 8 inch, we can consider that that is 6 inch. It will be better. And here the maximum tie spacing 12 inch. So I think number 3 bar 6 3 2, everything is okay, and everything is okay. I'll just go okay and see, is it B should be greater than 0, less than equal to S. B, okay, they have some error. So what I'll do, width 12 and depth 15, and then okay, and see is it okay or not. Just see, now it's okay, because your now capacity is 70.5, and in y direction the capacity is 336. So now our design check is okay, and if I click finish, it's creating a report. So see here, all mathematical terms or mathematical data have used here. You can study about that data as per ACI, what ACI 31814, and here we are seeing that the bar we have provided 6 into number 6 longitudinal bars and 3 tie bars, but here in x direction we have provided bar, but it should provide in. So if I click here, okay, again if I click calculate, and I'll change the reinforcement requirement. So, and here tie number 3 bar tie, and here I'll just go column reinforcement. Here I'll just give 2, and here I'll give 3. Okay, so okay, then I'm sorry, wait for some time. Okay, now it will also refresh. Now it's okay, right? So here in this way we are able to design our column as per our design requirement. So I hope you are well that how to design a RC rectangular column as per ACI 318. So thank you very much. Still stay connected till next video, and in our next video I'll just show that how to design a circular column, and day by day I'll try to cover everything. So thank you very much. Still stay connected till next video, and if you think that it was helpful for you, then don't forget to subscribe to my channel and also press the bell icon so that you get every update ever first.